Hello, welcome back to lesson 5.2. We're going to dive more into trigonometric functions, and 5.2 is all about the trig functions in the unit circle. So we're going back to the unit circle that we started talking about in 5.1, but also we talked a little bit about the unit circle. It was in actually lesson back in chapter 2. And the unit circle is a circle that has a radius of 1. And so you can see all the way around on the x-axis here, this is at the point 1, 0, and that can go up here at the top to 0, 1, and then over to the left at -1, 0, and then down at the bottom at where 6 o'clock would be on the clock at 0, -1. And so what we're doing is we're basically forming right triangles using the angle coming out from the vertex here, the 0, 0. Our x-axis and our y-axis here. And so when it comes out from there, starting at the x-axis and going up, it's creating this angle. And that radius going out is 1. And then when you bring from that point on the circle straight down, it forms a right angle. And so we are creating some perfect ratios. And these ratios, one is going to be called cosine and one is going to be called sine. And the cosine of t, that angle, is equal to x, the distance here. And the sine is the ratio of y, which is the vertical distance. And so you can see that we have, I'm going to show you my paper for just a moment. That wasn't it. Let's try it again. So our x and y coordinates are really our cosine t, comma sine t. So x is going to be your cosine t and y is going to be your sine t. And when we talk about our trigonometric functions, we're going to be talking about, there's 6 of them. And sine is always going to be your opposite of your angle over the hypotenuse of that triangle. Your cosine is going to be your adjacent length over your hypotenuse length. And your tangent is going to be your opposite over your adjacent. And I always learned it as so, S-O-H, ka, C-A-H, toa, T-O-A, so, ka, toa. And that's how I remember that. And you'll be able to make a note sheet for your exam so that you'll have that kind of with you. And you're going to want that note sheet, probably these things written out kind of with you while you're working on problems so that you kind of have them by you. Okay. Tangent is also sine over cosine. And then there are the other 3 trig functions that are sine is 1 over sine is equal to cosecant. And 1 over cosine is equal to secant. And then cotangent is equal to 1 over tangent. So we're going to use some of these pieces of information to help us find some things. But we're really using, to establish all this, the equation of a circle, which is x squared plus y squared equals r squared. And that's how we're developing that. When we're starting at the origin, then there's no shift. So it's just x minus 0. And then there's no shift because of the origin. No shift left and right, no shift left up and down. And that's equal to r squared. And so that's why it's just x squared plus y squared equals r squared. with a radius of our perfect, and our unit circle is radius of 1. So let's just jump in and start looking at some problems and seeing how these ratios work. So 13, 15, and 21 are asking us to find let me get there. Find the reference angle. So the reference angle is the original angle that we're referring to. So here, a negative 7 pi over 6 is asking us to find the reference angle for 13. So if we go backwards, a negative 7/6 pi, pi is over here and 2 pi is here at 0. And so if we go backwards pi, and that is negative 7/6 pi is another 1/6 that way. So the reference angle for each angle is going to be the original angle of pi over 6, because it's going to be 1/6 pi. So that's going to be our reference angle. 3/4 pi, its reference angle is going to be pi over 4. So it's basically the denominator is telling you what is the main angle that we're cutting. So in number 13, we're cutting our pi's into 6. So 180 divided by 6. So these are all like 30 degree is your reference angle here. And this 3 pi over 4 is really the reference angle, is pi over 4 is the reference angle. And if we take 180 degrees and divide that by 4, then we're going to have 45 degrees as our reference angle. And then on 21, it says the reference angle for negative 5/5, that reference angle is just 5/5. And if you take 180 and divide by 5, then you get 35, I think. No. 180 divided by 5. 36. And so pi over 5 is our reference angle for number 21. So what is the original base angle there? Okay. So 25 is asking us in this section to find the exact values of all the trigonometric functions for the following values of t. Don't use a calculator. So we're going to start with our base. This negative 3 pi is going around this way. So clockwise all the way and then back to another pi. So it's right here. So right here at this point, cosine and sine are a negative 1 and 0. So cosine of t and cosine of t is equal to a negative 1, and sine of t is equal to 0. And so tangent is always sine over cosine. So that's why I write them like this: sine, cosine, tangent. Tangent is sine over cosine. So tangent of t is equal to 0 over negative 1, which is 0. And then over here, we can just do the reciprocal. So over here, this would be 1 over 0. So cosecant is undefined at negative 3 pi. And cosine is just a negative 1 over 1. So that's still a negative 1. And then cotangent is going to be a 1 over 0 or undefined. So it's really kind of just getting used to these. Okay, so let's look at number 29. 9 is asking us to likewise find the 6 functions for a negative pi over 4. So starting here, we're going to go a negative pi over 4. So that's right here. This is also the same as a negative 45 degrees or a positive 315 degrees. So we're going to find just these here. So at this point, at 45, we can see in our book there that sine and cosine are square root of 2 over 2 because they make an isosceles triangle. So let's just go investigate this here for a moment. So you can see here that here we are in the book. I want to find this. So this table gives some great radian measure versus degrees, so you can kind of pull them out. But I want to show you this one here, example 2. So it says to find the sine and cosine of pi over 4 here at the bottom of page 417. We're looking at this equation for a circle, which is x squared plus y squared equals 1. Well, on an isosceles triangle, the two sides are equal. So it's just x squared plus x squared equals 1, which is 2x squared equals 1. So x squared equals 1/2. And so when we solve for x, we get the square root of 1/2 or the square root of 2 over 2. So cosine is the square root of 2 over 2, and sine is also the square root of 2 over 2. But in the fourth quadrant, cosine is positive, but sine is negative. So in the first quadrant, they're both positive, but in this fourth quadrant here, their sine is positive and cosine is positive. Cosine is positive and sine is negative. So sine of t is a negative square root of 2 over 2. Cosine of t is a positive square root of 2 over 2. And then when we do tangent, tangent is sine over cosine. So it's a negative square root of 2 over 2 times 2 over the square root of 2. Because you divide by fractions, you multiply by reciprocals. And those cancel and you end up with a negative 1. Okay. And so cosecant is the reciprocal of sine. So this is a negative 2 over the square root of 2, which is just a negative square root of 2 when it simplifies. And then secant is going to be a positive square root of 2. And then cotangent is just going to be a negative 1. So catch me back for the last half of the lesson, and we're going to begin with number 33.